Assalamualaikum warahmatullahi wabarakatuh and good morning. We are from Group K2 Final Year Design Project. So our title for our project is Production of Oleic Acid from Olive Oil.
For introduction, the theme for final year design project this year is production of raw material from renewable resource for non-alcohol based hand sanitizer. Therefore, we have choose the title production of oleic acid from olive oil. Well, our renewable raw material is crude olive from oil, and the usage of oleic acid is used as excipient in pharmaceuticals and emulsifying in hand sanitizer and solid agent in aerosol product, where it can conclude that oleic acid can be used as disinfectant and thickener in the hand sanitizer. Table in the right show chemical and physical properties of oleic acid, where our main process is oleic acid will react with water and we produce oleic acid and glycerol. For the supply and demand, the graph shows global supply and demand of oleic acid, where the graph shows supply and demand increase every year. And from the graph, we get demand, supply, and deficient. And from the demand and supply, we get our capacity 31,200 kilogram per day, which is around 10% of supply, which is fulfilled 6% global supply increases, 1.9% global demand, and 2.9% global supply.
Next, this is our summary for calculation for future potential economic for level 2, 3, and 4. Based on the gross profit we get from FPE level 2, 3, and 4, the final gross profit we get in our plan is about 269 million ringgit Malaysia. The detailed economic analysis we explain in the next slide. So this is the total capital investment that we have considered: the fixed capital investment, working capital, and land capital, and it's around 100 million ringgit Malaysia. For the total product cost, we consider the cost of manufacturing and general expense, and the total product cost is around 89 million ringgit Malaysia. And for the depreciation, the value of scrap is around 0.53 million ringgit Malaysia. The depreciation is 0.5 million ringgit Malaysia. And then by using the method do not consider time value of money, we calculate the return of investment. The MARR is around 20% and the ROI we get 33%. So the value of ROI is higher than MARR. Then the project is said to offer an acceptable return and it is attractive and profitable. For the payback period, from our calculation, we get 1.71 years. And then for the payback period reference, we get 3.51 years. So the value of payback period calculation is lower than payback period reference. So the plan is acceptable and flexible. And then by using the method consider time value of money, the value of net present value we get for our plan is around 74 million ringgit Malaysia. And then for the interest rate, we compute using analysis in Excel, we get around 34%.
Next, there are two types of economic analysis that we have done for our economic part, which is the first one is break-even analysis. From the first graph, we can see that the total income and total expenditure in the design plan at full capacity is considered to determine the break-even point at the first year. Next, at the second graph, the break-even point, which is 4,800 ton per year. The purpose plan capacity is around 10 million ton per year. Thus, this plan is said to be favorable since the capacity of the production is larger than the break-even point value. Next, this is the sensitivity analysis. So we have decided to sell our main product, which is oleic acid, at 12 ringgit per kilogram, while for the glycerol is 6 ringgit per kilogram. So the total income will be around 138 million ringgit. So the total net profit after considering the expenditure and also the tax need to pay, they are around 39 million ringgit Malaysia.
As a summary of conceptual design, so there are three main processes in our production, where it starts from production, hydrolysis reaction, where olive oil will react with water to produce oleic acid and glycerol. This is a method used in industry which is called as Colgate-Emery method. So oleic acid will be generated as the main product, glycerol as the byproduct, and olive oil and water to be the excess reactant. So we'll further separate it in the separation process, where we decided to use adsorption to separate the olive oil, flash to separate the water, and extraction to separate the glycerol. So for purification, we intend to remove the excess olive oil in a small amount in order to obtain a final product at a purity of 93%. This is the process flow diagram of our production, where we first feed in water and olive oil into the reactor. Hydrolysis reaction will produce the oleic acid and glycerol. When the pressure drop in flash vessel, most of the water will be flashed to vapor and it will be removed. Then we'll use the extraction where we feed in hexane as a solvent to separate the glycerol and water, which is denser. So the glycerol and water will be sent to evaporator to remove the water, and the glycerol will be concentrated and sent out as a byproduct. So for the other component, you'll be sent to distillation to remove the hexane, which has a lower boiling point, and the hexane removed will be sent back to the process use bag. And then we'll have an adsorption column here to separate the olive oil, where inside the adsorption is packed with silica gel. The silica gel will absorb the oleic acid from the olive oil. So the olive oil will flow out and recycle back to the process, while the oleic acid inside the silica gel will be dissolved by using acetone. So the oleic acid together with acetone will be sent to distillation column, where in here, the acetone, which has a lower boiling point, will be removed and recycled back to the process again, while the oleic acid will be sent out as a purity of 93%. This is the process flow diagram after heat integration, where we have done the pinch analysis to determine the pinch temperature, hot stream and cold stream. We have used a problem table method to determine it, and the hot stream will be 52 degrees Celsius and the cold stream will be 32 degrees Celsius. And the total energy recovery calculated will be 54%.
So now we move to PNID drawing. So this is our plant-like PNID drawing. So as we can see at the first unit, which is the reactor, the control system that we have at the reactor is temperature, level, and also flow rate. So at the second unit, which is the flash column, we have temperature, level, and also pressure controller. Next, we move to the liquid extraction column. We have level and flow rate controller. Next, for the distillation column 1, we have temperature, level, and pressure controller. For the evaporator, we have 3 types of controller, which is temperature, level, and pressure. For the adsorption column, we have flow rate and level controller, while for the distillation column 2, we have temperature, level, and pressure controller. So there are total of 4 types of control parameter in our PNID. For the temperature control parameter, the objective is to control the temperature of the unit at the set point by manipulating the flow rate of cooling water or the hot steam. So when the temperature exceeds the set point, the valve opening for the cooling water will increase, while for the hot steam, when the temperature exceeds the set point, the valve opening will decrease. For the pressure parameter, the objective is to control the pressure of the unit by manipulating the outlet flow rate of gases stream at the unit. So when the pressure exceeds the set point, the valve opening will increase, while when the pressure less than the set point, the valve opening will decrease. Next, for the level controller, the objective is to control the level of the unit of the liquid inside the unit at the set point by manipulating the outlet flow rate of the liquid stream at the unit. So when the valve opening is increased, the level exceeds the set point, while when the level less than the set point, the valve is closed. For the flow rate control parameter, is to control the flow rate of the fluid into the unit at the set point by manipulating the inlet flow rate of the unit. So when the flow rate exceeds the set point, the valve opening will decrease, while when the flow rate less than the set point, the valve opening will increase. So for the valve selection, there are 3 types of valve that we use in our PNID, which is the first one is blow valve, next gate valve, and last but not least, the ball valve. For the pressure relief system, there are 2 units that we apply this system, which is reactor R101 and extraction column L101. The type of valve that we use is conventional PRV, which is spring-loaded pressure valve. So the objective is to avoid the overpressure inside the unit.
For the safety law and regulation related, there are 3 laws. First law is Environmental Quality Act 1974. There are 6 regulations under EQA 1974, where the further explanation about EQA 1974 will be explained in the waste slide. For the second law is Factory and Machinery 1967, and last but not least is Occupational Safety and Health Act. There are 4 regulations under OSHA 1994, and we have applied all 4 regulation under OSHA, WENDU, hazard system, and HIRAT. For the hazard system, there are three types of source, which is hexane, acetone, and reactor operated at high temperature and pressure. For the receptor, there are two types of receptor, which is butyl nearby and butyl nearby. And the receptor for all type of source is same. For the transmission part, the transmission part for all type of source is almost same, which is the thermal radiation can cause fire, overpressure that can cause explosion, and dispersion with wind that can cause toxic. For the barrier, there are two types of barrier, which is physical and non-physical, and for all types of source, the barrier are same. From the hazard system, we have do the hierarchy for each unit where we have identified the hazard and do the risk assessment and risk control. And one of example that give the highest risk level is overpressure inside the tank that can cause explosion. And the existing control is work instruction, emergency response plan, and high pressure alarm. And additional control measure is ensure no initial source nearby.
Next, for the plan location, based on our plan design, 5 locations are chosen for consideration, which are Chukai Terengganu, Butterworth Penang, Pasir Gudang Johor, Kuantan Pahang, and Tanjung Kupang Johor. Table show the characteristic of each location, and the next table show how mark scoring is given to each location. So this table show the mark scoring for each location, and from the table, Pasir Gudang show the highest total mark due to the highest score in laborability, public facility, and residential distance. So this map show our plan that we want to propose at Pasir Gudang, Johor. So for the plan layout, we are considering using the guideline for seating and zoning of industrial from Department of Environment. So this basically is our plan layout, which we are consider based on the economic and safety consideration. This is the one direction will be from west to east. So for the installation of hazardous unit operation, so that the potential hazard to the personal equipment can be avoided. In addition, based on the process requirement, the arrangement of unit operation is minimized in our plan layout.
So for process waste management, first we identify two types of waste in our production, which is solid waste, catalyst, and liquid waste, wastewater. So we have come up with waste minimization step to reduce the waste generated, where we first eliminate the source, which is the solid catalyst, and recycle the solvent used in our production. And the wastewater generated will treat before we discharge it, and the sludge generated during the wastewater treatment will be disposed. And the regulation related to this process waste management will be Environmental Quality Act EQA 1974. So under this EQA, two main type of regulation which are related to our process waste management will be the Environmental Quality Industrial Effluent Regulation 2009, so which we use it for solid waste, which is a sludge. And the other one is the Environmental Quality Scheduled Waste Regulation 2005, where we use it for our liquid waste, which is the wastewater. So we have decided to use biological treatment and chemical treatment to treat our wastewater. So here shows the wastewater treatment plant, where in the wastewater it consists of the glycerol and oil mainly. So by following the standard A, which is a COD should be under 80 and the BOD should be under 20, we have suggested this wastewater treatment plant in order to reduce the initial COD from 15,421 mg per liter and initial BOD 10,538.75 mg per liter to a value lower than standard A stated, which is 77.72 mg per liter and 19.91 mg per liter. So the wastewater treatment plant suggested start with by using biological treatment, which is the activated start system. And then we move on to acidification, where we intend to demulsify the glycerol inside soluble in the water. After the glycerol is being separated out during the acidification, we'll use the coagulation by using polyaluminum chloride and lime together as the coagulant to coagulate and flocculate the glycerol into a clump, and you will settle down in a settling tank. And the biomass will be generated out as a sludge, while the treated wastewater will be discharged to the environmental.
So as the conclusion, oleic acid produced from olive oil can be used as thickener in hand sanitizer. For this production, the plant capacity has been set to 2,300 kg per hour. Hydrolysis reaction will be the main reaction for this production. So the payback period is 1.7 years and ROI is 0.33%. So this plant is profitable. Johor Pasir Gudang has been selected for our plant location. Biological treatment and chemical treatment is used in wastewater treatment plant to reduce the COD and BOD level. So the hazard system and HYRAC is being used to mitigate any hazard. Pressure, for flow rate control, and temperature and level is used in plant to ensure safe operation and steady operation. So that's all. Thank you.